are going to do these ones, but I'm actually going to grab a couple from yesterday's that we didn't get to, that I didn't realize weren't in here. So hold on just 1 second. Not abandoning this. I'm just grabbing something we didn't do yesterday that I wanted us to do. Boop. Sorry, my screen's freaking out. There we go. This one. We're going to start here, and then we'll go to the other one I just had up there. Okay. Because I want us to do some more with our inequalities before we start tossing weird things in like absolute values and stuff. So here we're given this kind of sandwich inequality, which we can approach it exactly like we do an equation, or we can split this up into pieces if this having two signs in here messes with your head. Either way is fine. I think it's easiest to kind of live with it as it is. We're just solving from the middle, and we have to go out in both directions. So what we have is that this statement is currently between 3 and negative 5. So 3 is bigger than 4x minus 2, which is greater than negative 5. So if I want to find out the rules on x, what are we going to need to do to get my x by itself? Add 2. I need to add 2. That's a 3. There we go. Add 2 here. So I need to add it to the 3 and to the negative 5 as well. So we're going to have to add this in 3 places. Plus 2, plus 2. So we're going to have that 5 is greater than 4x, which is greater than negative 3. Then what are we going to need to do to get my x by itself? Divide by 4. Divide this piece by 4. Divide this piece by 4. Divide this piece by 4. Everybody. So we're going to have our 5/4 is greater than x is greater than negative 3/4. It's not an interval notation, but that's the solution. But we want to put it in interval notation, which, especially when it's written kind of this funky, weird way, is kind of hard to see. So this is when sometimes it helps to sketch it on our number line, like we did kind of in that table that we filled in yesterday, where I know negative 3/4 is going to be pretty small, and positive 5/4 is bigger, right? Negative 3/4 is in fact smaller than positive 5/4. On each of those ends, are we going to do open circles or closed circles? Open circles, because we have greater than, not greater than, equal to. And since x is between them, we are going to color in between them. So our interval is going to go from negative 3/4 at the smallest to positive 5/4 at the biggest. Since we used greater thans and we used open circles, we're going to use parentheses on both of them. When we have an equals to, we use a closed circle and our square bracket. If we do not have the equals to, we use our open circle and a parenthesis. Okay? Questions on this one? Okay, let's do the one on the right. What are we going to need to do here? Oh, why did it jump like that? Hang on, give me that back. There we go. Jump the page on me. So what are we going to do? Multiply everybody by 5. This 5 and that 5 cancel out. So we're going to have 15 is less than or equal to 2x minus 9, which is less than 35. Then what should we do? Add 9 plus 9 to all the pieces. I'm glad we think it's nice. What do we get next? We have 24 is less than or equal to 2x, which is less than 44. And we divide absolutely everybody by 2. So lovely, isn't it nice? We get whole numbers this time. So we have that 12 is less than or equal to x, which is less than 22. Yep, so it may help to put it on the number line. We're going to use the number line on Tuesday and Wednesday, so I'm just keeping us fresh on it. We're going to have our 12, which gets a closed circle because it's an equals to, and our 22, which gets an open circle, and we are coloring in between. X is between them. So we're going to have that we have square bracket 12, comma 22, parenthesis. Questions on those two? One more like this before I throw absolute values at you. Oh, and it didn't copy over. Love it. So it's 2x minus 3 times 4x plus 5 is less than or equal to, I know, 8x plus 1 times x minus 7. Doesn't change what we do. We still want to solve this. I want to find out what relation x has to the other numbers. So what should we do? Multiply everything else. Distribute. Box, however you choose to multiply. Multiply whatever way your little heart desires. So on my left-hand side, when we multiply this out, 2x times 4x gives me 8x squared. 2x times 5 is 10x. Minus 3 times 4x is negative 12x. So we have minus 2x minus 15 is less than or equal to, same thing on the right-hand side, 8x times x gives me 8x squared. 1 times x is 1x. Minus 7 times 8x is negative 56. So we wind up with negative 55x minus 7. I heard a what on that one. Where did I lose this? Did we see it? Or did we just... Did I lose you? I heard a what? Okay, if you have no clarifying questions, I'm just going to keep going. Because now we look at this and we go, ew. What should we do? Yeah, I'm going to try and get my x squareds together. And that's really going to help us. Because if I subtract 8x squared from both sides, what's going to happen? They cancel out. They're going to eliminate out. We are going to wind up with no x squareds. We love that. So now I have minus 2x minus 15 is less than or equal to negative 55x minus 7. Now what should we do? Yeah. If we add 55x, if we add the smaller one, we're going to not have negative numbers that play games with our signs. So we'll always figure out which one's smaller. Negative 55 is in fact smaller than negative 2. So if you move the smaller one, we won't have to deal with the negative changing signs. So if I add 55x to both sides, that's going to give me 53x minus 15 less than or equal to negative 7. Then what? Add 15. So we're going to have that 53x is less than or equal to 8. So what is x less than or equal to? 8 over 53. So what's our interval going to be? Negative infinity to 8 over 53. Bracket. So parenthesis negative infinity, because we never put a bracket on infinity, because infinity is an idea, not a number. And we put a bracket on 8 over 53 because it has that equals 2 on it.
Which one is the answer?
The interval. This is what we're looking for as our answer. We just don't solve it as an interval because it wouldn't really make any sense. So we have to solve it algebraically, but our answer is going to be this interval. Okay. Questions on these ones? Because now I'm going to toss a weird at you. A little bit. We're going to look at some absolute values. And we're going to work with absolute values today and Monday. Or Tuesday, because I won't see you Monday. And Wednesday. Okay. So let's think about it on this first one. If I know the absolute value of x is less than 3, what does x, not absolute value, what does x need to be between? Well, big problem, yeah, between negative infinity and infinity. But if my absolute value, my distance from 0, is less than 3, what is the very smallest my x could be and have the absolute value be less than 3? Negative 3. So when we have these absolute values, we think about it as this is my, whoa, wrong pen. This is my distance. My distance is less than 3. So x has to be between 3 and negative 3. Ooh, heard that one be weird. So if we think about our number line. I'm going to put 0 in the middle. We know that x could be less than 3. That's what it says originally. And if it didn't have the absolute values, we would just continue on forever. Right? It would go like this. But it's the absolute value. So if I took the absolute value of negative 4, would that be true here? No. So I need to know when its distance stops being less than 3. So it's not going to keep going forever. It's going to stop at negative 3. If it was negative 3, it would be exactly equals to. So since this is a less than, we're going to keep using less than. It means we'll have open circles. So our interval is going to go from negative 3 to 3. And these are weird to wrap our brains around. But questions on this first one? What's up?
You have to, like, let's say, on like the test,
Mhm.
do you have to draw the line, or can the answer just?
For these ones, no. We will have times when we will need the line for another thing, but I'll show that to you when we get there. Tuesday. All right, so let's do one that's a little bit more complicated. The one on the right. Absolute value of 2x plus 5 is less than 4. So we know that this distance has to be less than 4. So that chunk, my 2x plus 5, is going to exist between 4 and negative 4. So we're building one of the weird sandwich ones that we started with today. Now we solve it the exact same way we did that first one. So what are we going to do first? Careful. Subtract 5. So we're going to subtract 5 here, subtract 5 here, subtract 5 here. It's going to give us negative 9 is less than 2x, which is less than negative 1. So my x is going to wind up between negative 9 halves and negative 1 half, because we divide all the pieces by 2, right? You see where those are all coming from? So our interval answer is going to be our negative 9 halves to our negative 1 half, and everybody's getting parentheses because it's a less than, not an equals to. Okay? So in homework 626, you will see these absolute values come up. We're going to do some more of the weirder absolute values, the ones that have fractions and things like that, on Tuesday. Okay? Tuesday and Wednesday, we're still going to be taking notes. Thursday we'll review. Friday's your test. On your way out, I hear on my tray is the review if you want it. I will always have it for you the weekend before the test in case you want that time on the weekend to work. Okay? So that is the chapter review right there. And I'm going to take my book and dodge out the way because I see y'all coming. Remember that we are still going to be doing notes on Tuesday, Wednesday, so there's stuff on there we haven't talked about yet, so please don't panic.